Hello. Does this screen look familiar? It should. It was the last screen we saw in the part one of this presentation. We're going to pick up part two with it, and that was like 29 minutes. And it's kind of like that the most I'd like to have these videos be, because I get it. Okay. Anyhow, they're not the most exciting thing to watch. So now we're still on risk communication, still chapter 2 book. This is picking up in the middle here, kind of. Risk communication tools for safety professionals. 3 of the tools that we just talked about are used to advance risk communication are presented in more detail, which are the plan, do, check, act model, a risk-based decision-making model, and the risk assessment triggers. And that's what we're going to cover here in the second part of this presentation of chapter 2. Risk management tool number 1, the plan, do, check, act model. Purpose of it, plan, do, check, act, PDCA model, is an iterative, which that means repeating, systematic approach that enables an organization to control and continually improve a system, process, or product. The PDCA model, which is an endless cycle, provides a simple and effective four-step process for problem solving and managing change by testing and refining ideas before fully implementing them. Application originally developed by Walter Shewhart in the 1930s as the Shewhart cycle, or Shewhart learning and improvement cycle, which combines management thinking with statistical analysis. This model was later made popular by W. Edwards Deming in quality management methods as a Deming cycle. If you're not familiar with Deming, he's back in this goes back a ways. I'm going to say 40s and 50s. I'm not exactly sure. Was trying to promote his quality management style to the big automakers in Detroit. And then they weren't part of it. Nah, we're okay. We don't need you. So I went over to Japan, and guess what? You know, that's what happened. That's how he was a big part in making the automobiles manufactured over there quality products and help their industry. So the PDCA model can be compared to the 4-step scientific method, which includes the following. This is the 4-step scientific method. Create a hypothesis. And you say, okay, this is what we think it is. Perform a base experiment based on a hypothesis. Analyze results and draw conclusions. If you're in any high school, probably chemistry classes or something like that, you probably kind of did something like this. The systematic approach used by teams trained in the method can be used to solve any type of problem or improve any system. You create a hypothesis. You say that, if I stick my hand in this water, it's going to get wet. You perform an experiment based on a hypothesis. You stick your hand in the water, analyze the results. Yeah, it got wet. So then draw conclusions. All right. The hypothesis was valid. PDCA, also known as continual improvement cycle, is used by organizations as a management system for continuous improvement of various business aspects, such as quality, production, the environment, and safety and health. The cycle provides a practical problem-solving process for systems that repeat frequently, and in particular, for new systems and processes that are being designed and anticipated, existing systems and processes that frequently reoccur, or recur, I prefer it. Systems and processes that are incorporating Six Sigma and lean concepts, and the exploration of possible new solutions to existing system problems. The PDCA model is a methodical, consistent process for measured growth and improvement, and may not be appropriate for acute situations requiring immediate actions like emergency response. Makes sense. You have emergency response, you're not going to sit down and get a committee meeting. As described by its name, the PDCA is a 4-step process. Plan, define the problem, identify causes, establish objectives, develop a plan. Makes sense. Plan, do. Implement the plan. Document the observations. You did it. You thought this is what we're going to do. This is what we do. And what happened? Check, measure, and analyze effectiveness, and act. Standardize success. If it works, adjust for improvement. If it works, then you standardize amongst everybody else or whatever. And you always adjust for improvement. It is used by a team of stakeholders who are typically trained in the process steps, and it requires effective communication among stakeholders in the exchange of ideas, solving problems, and progress status reporting. The process steps are further described in the next several slides. As we talked about in the first half of this, communication is it's kind of trite sound, but it is a two-way street. When you communicate, You telling me something is not communicating. You telling me, and me telling you, agreeing with you, and us discussing it, so you know that I understood it. That's communication. So here you go. This is the process of the Plan, Do, Check, Act. Assemble a team. The PDCA model involves a team approach to improve a system or process. A team leader and team members who have the skills and experience in the PDCA process and the necessary expertise in the areas that need improvement should be selected. Training for team members and a clear team charter providing guidance on the team's purpose and scope are important aspects of the team assembly process. In other words, you're going to get a team together. They have to be, if you're going to make an improvement on a job in a plant, a particular operation, these people need to know what it is and be familiar with it to be part of the team, of course. And you have to know what you're doing with the Plan, Do, Check, Act model. And you have to have some kind of scope. What are you trying to do? You're trying to improve quality. You're trying to improve productivity. Establish communication. As required by ISO 31000, a communication plan should be established up front and continue throughout the PDCA process. Team members and stakeholders who are involved or are affected by changes must be kept informed of the timing and status of improvements, and communication of general progress should be provided on a regular basis to all stakeholders. Plan. The most critical step of the PDCA model, the plan step, involves the team identifying the problem and possible solutions. Specifically, the plan step requires them to define the problem, identify causes, establish objectives, and develop a plan to meet the objectives. Identify and define the problem. This is still the plan. The problem must be clearly identified as defined as to its context, purpose, and scope. Much like goal setting, a problem statement with specific, measurable, attainable, relevant, and time-based, and that's called SMART, specific, measurable, attainable, relevant, time-based elements, is often used to provide a clear meaning to team members and stakeholders. B, identify causal factors. The underlying causal factors or root causes of the defined problem must be identified and understood in order to solve the problem. Techniques such as multiple why, 5 whys, root cause analysis, cause and effect diagrams, and process mapping can be used to drill down past the symptoms to the base of causal factors. Now, I don't like it when they do this, and they do this in textbooks all the time because they want to have this, they're writing this textbook for their doctor or something like that, and they want to have different words for the same thing. Root causes, causal factors, root causes, same thing. Why they just don't use root causes, which everybody's kind of familiar with, I don't know. When I say causal factors, they're talking about root causes. So 5 whys is a good technique, and it's just keep, okay, why this happened? Why? You keep asking why. Sometimes it's called 5 whys because usually they say by the time you get 5 of them, you're going to be at the end of it. And and one, if I remember it right, was a cause of, there was oil on the floor. People were slipping, sliding on the floor. So they said, well, why is there oil on the floor? Well, because it's lip dripping from this piece of equipment out of the oil ring. Well, why is the oil ring leaking? Well, the oil ring leaking is because the purchasing department didn't buy it from this the individual manufacturer. They bought it from some offsite, and it doesn't fit very well. Well, why did they do that? Save money. Well, so you get right down to the root cause is the purchasing department should have been buying parts specified by were they making that decision? Who knows? But should have bought parts for this piece of equipment from the manufacturer of that piece of equipment. And so that's how you dig down into something. Why was oil on the floor? Because the purchasing department trying to save money. Believe me, that happens in real life. Establish objectives. Upon defining and understanding the problem and its cause, the team sets the objectives required to address the problem. Objectives should be stated as having SMART elements, capable of delivering their desired results, and being fully understood by team members. Develop a plan. With the objectives in mind, the team develops a plan that will be implemented to address the stated problem. The plan should include required resources, assigned responsibilities, and a timeline. Gantt charts and other project management tools should be used to organize and manage the plan. The Gantt charts are the timelines where everybody has to do something, and they're really useful in big, huge projects, but for small projects, not as much. Do, the second step in the Plan, Do, Check, Act model. In the second step, the plan is implemented as designed and then observed for any issues, unexpected consequences, difficulties, or other effects. Documentation of the plan's execution and its results effects should be captured for use in the check and act steps and communicated to team members and affected stakeholders. Check. After plan implementation, the results are captured, analyzed, and compared against the expected results or objectives to determine any differences. Any deviation from the original plan or necessary modifications should be noted. And act. Information from the check stage is collected and evaluated. If it is determined that the implemented plan achieved its objectives, the plan is then standardized. If the results show that the plan did not meet its objectives, adjustments or corrections are evaluated to make the needed improvement. The PDA cycle encourages a methodical approach to problem solving and implementing solutions. Following the PDCA model steps help ensure continual improvement. Now, this is risk management tool number 2, risk-based decision-making model. Another acronym here, RBDM. Risk-based decision-making, RBDM, is a process that organizes information about possible unwanted outcomes into an orderly structure that helps facilitate decision-making and more informed management choices. RBDM is, in essence, the practice of risk management in the decision-making process. It provides a consistent, systematic, structured means of making informed decisions in a timely fashion. Its purpose is to reduce uncertainty about the effects and outcomes of the selected decision. Application. The model for making risk-based decisions can and should be applied to any important decisions, especially those where uncertainty exists within an organization. RBDM takes into consideration several key questions about risk relating to the decision to be made, which are: what can go wrong? How severe is the potential outcome? How likely is it to occur? There you go, severity and likelihood coming up again. Is the risk acceptable or unacceptable? And does the risk require reduction? As you can see, if you have severity and likelihood, you plug that into your risk matrix, 5x5 risk matrix, and then you get the acceptability or unacceptability of the risk. Does the risk require reduction? The process steps shown on the next slide are a structured sequence of risk management actions that identify and acquire information that is needed to make a specific decision. From beginning to end, the process requires effective, timely, and accurate communication among decision makers and stakeholders. Communication. So there you go. This is the communication consultation, risk-based decision-making process module. Identify the decision, determine context, decision makers, stakeholders, options, influential factors, assess risk, determine needs, select risk assessment tools or general information, make decision, evaluate information, assess options, select option based on risk, monitor effectiveness, evaluate results, assess impact, make refinements, and communicate results. So process steps identify the decision parameters. The context for a selected decision is first determined and defined. This will include the subject matter, stakeholders involved, potential options or choices for the decision makers, the uncertainty surrounding the decision, and any influential factors that need to be considered. Assess risk. The information needed to reduce uncertainty and make the decision is determined. Specific data and information needed is identified. A review of available risk assessment tools is made, and the tools that will gather needed information are selected. A selection of risk assessment is available from various sources, including, I won't read this manual and other risk assessment texts. The selected risk assessment methods are performed by competent risk assessors who generate the risk-based information. Then make a decision. The risk-based information is evaluated in the context of the decision to be made. Available options are assessed as to their risk reduction potential and other benefits, as well as their costs. The hierarchy of controls and the as low as reasonably practical principle are applied to the selection process. The option with the lowest risk level, greatest benefit, and lowest cost is selected and implemented. Monitor the effectiveness, or monitor effectiveness. Monitoring of the decision's implementation and effects is performed and recorded. A business impact analysis or other method can be used to determine and document the decision's impact. The results of the decision and impact analysis are compared to the expected outcomes to determine if the decision was successful or if adjustments are needed. Throughout the decision-making and implementation process, it is important to acquire adequate input and feedback from the stakeholders. The results and actions taken should also be communicated to stakeholders. So now we're risk management tool number 3, risk assessment triggers. The purpose of risk assessment triggers is to give an organization a consistent and clear understanding of when, where, and how risk assessments will be performed. A trigger is a risk source, event, situation, or occasion that signals the need for a documented risk assessment. Risk Assessment Institute. Okay, according to ISO 31010, a risk source is an element that, alone or in combination, can create risk. Triggers can be from internal or external risk sources. Application. According to the defined risk criteria, organizations should determine the events, conditions, situations, and tasks that require a formal risk assessment. In other words, the risk trigger is not the assessment, it's just triggering it, saying, okay, this now we need to do it. A written protocol for the application of risk assessment within an organization should include the specific internal and external risk sources that trigger the need for assessment. As required in ANSI Z10, certain triggers for risk assessments include design safety reviews for new designs and redesigns, assessment of risk associated with planned changes, and a management of change protocol. And management of change is an important part of process safety management, which we'll cover later. Review of potential new risks from planned purchases and procurement, and qualification and risk assessment of selected third parties, such as contractors, suppliers, and vendors. Again, qualifications, selection of contractors and monitoring is important in process safety management as well. As an organization matures and becomes more effective in reducing risk, that's a hopeful thing. That doesn't always happen, but it should be. One of the reasons it doesn't always happen is turnover. So maybe the vice president you had was the leader of the production was really safety conscious, and he's gone now, and the guy comes in, all he cares about is production. That happens in real life. So hopefully it matures and becomes more effective in reducing risk. As accepted risk levels move lower, this progression toward more effective risk management may broaden the risk sources or triggers used to capture risk assessment for tasks and events that previously were not assessed. As part of an organization's risk management process, policies and procedures for assessing risk should be established and communicated to stakeholders. The overall goal of risk assessment and risk management is to achieve and maintain acceptable levels of risk for the organization. The risk assessment protocol should include risk assessment triggers. In determining the triggers for formal risk assessments to be conducted, a review of the organization's existing risk criteria and acceptable risk level is needed. Triggers for risk sources that have potential for unacceptable risk should be identified and included in the organization's risk assessment protocols. Such triggers should include risk sources that occur internally, as well as those that originate from outside the organization. The risk assessment protocols and triggers should be reviewed and updated periodically to reflect changes and needs within the organization. The process of establishing and reviewing risk assessment triggers is shown on the next slide, or figure 2.6 on page 47 of the book. Establish risk assessment protocols, incorporate risk criteria and acceptable risk level in the trigger protocols, determine specific triggers and communicate, review and revise protocols as organization matures. So establishing an inventory of existing risk sources require a review of both internal and external sources. First, a review of internal risk sources should include routine and non-routine tasks performed in the organization. Tasks that are performed by a large population of workers should be considered, especially those with additional risk sources. Jobs or tasks that involve electricity, high pressure and stored energy, gravity, moving objects or equipment, chemical, hydraulic, or pneumatic pressure, extreme temperature, hot work, or other sources should be listed as triggers for risk assessment. This is good advice. The review should also include any tasks that present an exposure to physical agents such as laser, welding, and non-ionizing radiation, air contaminants such as dust, particulates, smoke, gases, and mists, chemical mixing, use, and cleaning, noise and vibration, extreme temperatures such as heat stress, hot surfaces, and cold environments, or ionizing radiation. In other words, any of those things should trigger a risk assessment. You're doing something with chemicals, you'll have a risk assessment. A list of common or universal triggers for conducting risk assessment is presented in Table 2.1 on pages 48 49 of the textbook and in the next several slides. These are going to be common or universal triggers for conducting risk assessment. Internal triggers, design or redesign. So new facilities, process, or systems. This is by now, even by now, into this, you probably should figure that one out. New methods, new products and services, major capital projects or expenditures. And where do you see this before? New products, process systems, in any OSHA training. And that's when you have this happen, you look at your training and do your training and retrain people. Internal triggers, change management, modification to existing facilities, processes, or systems, additions or expansions to existing operations, changes in methods or materials, change in setting or environment. So basically, anything that changes of any extent need to be trigger a risk assessment. High risk tasks. There's confined space entry, electrical or other high energy work, elevated work, hazardous chemical processes, hot work, line breaks, line breaking, and energy isolation, work around moving objects. They probably mean moving machinery, or manual moving objects like forklifts too. That says both. Manual exertion, error prone or error critical jobs, tasks. Non-routine tasks, adjustments and debugging, construction and excavation, things that don't happen all the time, dismantling, demolition, disposal, erection and installation, maintenance, service, and repair, transport and move equipment. These are usually non-routine tasks. And when you do that, then that would trigger a risk assessment. Incidents, fatalities. Yeah, definitely that should trigger risk assessment. Serious mishaps and near misses, at-risk observations, incident trends, environmental releases, fire and explosion, of course, emergencies, upsets and breakdowns. So any of these should trigger a risk assessment. Physical and chemical agents, chemical exposure, noise and vibrations, radiation, both non-ionizing and ionizing, extreme temperatures, hot or cold. Routine tasks performed by a large population of workers. That makes a lot of sense. Manual handling and repetitive tasks, transportation, complaint and concerns, at-risk observations, complaints and concerns. Please, whatever you do, don't ever, if an employee comes to you with a complaint or concern about something related to safety, I always put that pretty much at the top of my list unless something else is really important going on, because you want that employee to know that you listened to them and took it and acted on it, what they said. Or if you didn't act on it for some reason, you went back to them and told them why. You said, okay, I appreciate your concern, but we couldn't do what you suggested because of this or that. But we did maybe do something else that could help it make it safer. You want those, you want to value those employees. You care enough to do that. Purchases and procurement, new chemicals, substances, or materials, new equipment, machinery, or tools, new technology, physical assets. That's why when you have a team on a problem solving like that, you get people involved in purchasing, so they understand that they just can't slough off safety things that are on the equipment, like fixed ladders and that type of thing. And also they have to understand they can communicate. They have to communicate too, so communicate to you what they're going to do. So what they communicate to actually all the stakeholders. But okay, this is what we're going to do. We're going to get this chemical in. Now that gives you a chance to look it up and find out what has to be done about this chemical, rather than just showing up at the door. Third-party interactions, contractors, vendors, and suppliers, temporary workers. Temporary workers are always a challenge because they turn over a lot. And so usually you relegate them to the entry-level jobs that don't require a lot of training. I have issues at some plants where they temporary work. Well, how can I train them? I don't have time to spend half an hour and a half training somebody. So I'll put them at a job that doesn't require an hour and a half of training. Put them in a job that requires 5 minutes of training. Some jobs are like that. You're working at the end of the line. You're just taking this. Okay, you take these off here and you put them over there. And, that's what you need to do. temporary workers. And after they're a while, then you can move them up to something more complicated. Customers and visitors, rentals, leases, multiple employee work sites. External requirements, customer requirements, legal requirements, maybe regulatory requirements. Natural disasters, floods, tornadoes and wind, hurricane, earthquake, severe weather. Intentional threats, cyber threats, unauthorized entry, sabotage, civil unrest. Now, from a prevention through design standpoint, figure 2.7 on page 50, also the next few slides, presents a process flow of hazard identification and risk assessment triggers through the 5 phases during the lifespan of a system, process, or activity. Occupational safety and health professionals should place emphasis on the need for risk assessments early in the design and redesign phases. So again, we're going to talk about the 5 processes. Here's the 5 processes, risk assessment triggers during a system's lifetime. The 5 phases, design phases. In other words, okay, we can design something, and maybe it's a plant layout, maybe it's a piece of equipment and process. The build or purchase phase, maybe you're going to buy it. Again, purchasing comes into effect here. Building it, install it, put it in, operate it, we're going to run it. That's probably the longest phase of this, hopefully. If you don't, and you may run it for 30 years, who knows? And then decommission phase. So we're going to talk about more of these phases in more detail. The design phase, conceptual, has to be somebody has to have an idea, concept of it. External requirements, physical agents. Preliminary design, external requirements, again, physical agents, third parties, natural disasters, intentional threat, high risk tasks, non-routine tasks. So that's going to be pretty repetitive in here. Design or redesign, a design safety review, look at the design for any safety issues. Build or purchase phase, specifications have to be done. Pre-build plan, procurement specifications. Build or purchase, who's going to check to be sure that the product coming in, it meets those specifications. You need build or purchase, which one are you going to do? Again, non-routine tasks, high-risk tasks, third parties, physical agents, procurement. Install phase, pre-plan the install. High-risk tasks during the installation could be. Non-routine tasks, probably a lot of those during an installation. You might contract this out. Third parties, physical agents. Debug and setup, high-risk tasks, non-routine tasks, third parties, physical agents. And the operational phase, routine tasks. You got this machine coming in, you're running it now. So you have lots of routine tasks, right? High-risk tasks, maybe. They may be routine as well. Physical agents, incidents, maybe they could trigger an assessment. Third parties, natural disasters, intentional threat, external requirements. Maintain and service them, equipment. We know what doing maintaining and serving, what you need to do with it, right? Lock it out. Non-routine tasks, high-risk tasks, third parties, physical agents. Repairs, I don't know why that's not maintenance service, repairs, kind of the same thing. Modify or change in the operational phases, change management, design safety reviews. Decommission phase, shut it down. Non-routine task, high-risk task, probably going to be third parties involved. And after you shut it down, you dismantle it. Non-routine tasks are going to be aplenty there. So high-risk tasks, more likely. Again, third parties and physical agents may be present. Disposal. Now you're done with this piece of equipment. You're going to get rid of it. So you have non-routine tasks again. They could be consequential. They could be lifting huge pieces that are no longer needed, moving them out of the plant, shipping them somewhere. Who knows? Non-routine tasks, external requirements, third parties. And that's the end of chapter 2. There's some good stuff in this chapter. Read it. Please watch this video and actively listen to it. And by all means, be safe.